Do you want to check if 25,871 is divisible by 2, 3, 5, 11, or all of them just by looking at it? If yes, then this video will teach you this shortcut. Hello guys, welcome to NoorulRiazi, and this is your mathematics teacher Nuruddin Qureshi. And today we will learn the shortcut to check the divisibility of any number. So let's start with our lecture. So now this shortcut will enable you to check the divisibility of any number not by dividing them but just to check certain criteria for every divisibility. So let's start with the divisibility of 2. For the divisibility of 1, you already know that all of the numbers are divisible by 1. So we will start with the divisibility of 2. So all the even numbers are divisible by 2. That means the numbers ending with 2, 4, 6, 8 or 0. So let's see some examples. So 6. 6 is a one digit number, so it is ending with 6. That means the unit digit of 6 is also 6, so it is also even number. 38. So 38 is ending with 8, so it is also an even number, so that means it is divisible by 2. 2,465,674, so it is also ending with 4, so it is also divisible by 2. And this number, as you can see, that all of the digits are odd except the last digit. So if the last digit, which is the unit digit, is even, then the whole number will also be even. That means it will also be divisible by 2. So let's check the divisibility of 3. So this is the interesting one. So to check the divisibility of 3, all you have to do is to sum all the digits of the number. So that sum should also be divisible of 3. So let's see some of the examples. 18. As we already know that 18 is divisible by 3 because 3 into 6 is 18. So let's check it with our method. So all we have to do is to just to add the number of digits of 18. So 1 plus 8, that is equals to 9. So as you know that 9 is divisible by 3, so this 18 will also be divisible by 3. So let's take a bigger number, 2346. So let's add all these digits. So 2 plus 3 is 5, 5 plus 4 is 9, and 9 plus 6 is 15. So since 15 is divisible by 3, so 2346 will also be divisible by 3. So now this is a difficult one, but all you have to do is to add the number of digits. So 7 plus 3 is 10, 10 plus 9, 19, 19 plus 5, 24, plus 7, 31, plus 3, 34, plus 6, 40, and plus 2 is 42. So 42 is a multiple of 3, so this complete number will also be divisible by 3. So let's see how to check the divisibility of 4. For the multiples of 4, their last two digits will also be divisible of 4. So for example, we have 32. So 32 is already a two-digit number, so it is divisible by 4. Then we have 2,465,624. So the last two digit is 24. 24 is already divisible by 4. So this complete number will also be divisible by 4. Then we have this number. So here the last two digits are 76. So 76 is divisible by 4. So this complete number will also be divisible by 4. So for the divisibility of 5, the numbers should be ending with 0 and 5. So for example, 45, this is ending with 5. 2,465,670. So this is ending with 0. So this is divisible by 5. Then we have this complicated number, but the last digit is 5. So this is also divisible by 5. Now, for the divisibility of 6, the numbers should fulfill the criteria of divisibility of 2 and 3, which we have already seen in the last couple of slides. So that means the number should be ending with 2, 4, 6, 8 or 0, and the sum of all digits should be multiple of 3. So for example, for 18, the last digit is 8, so it is an even number, and the sum of digits are 9. So 9 is divisible by 3. So this 18 is also divisible by 3. So since 18 is divisible by 3 and 2 both, therefore it is also divisible by 6. Similarly, for 2346, so the last digit is 6, so it is even, so it is divisible by 2, and the sum of all digits is 15. So 15 is divisible by 3, so fulfilling the criteria of divisibility of 2 and 3, we can say that 2346 is also divisible by 6. Similarly, this number ending with 2, and the sum of all digits is 18, already divisible by 3, and ending with 2 will make it divisible by 2. So this number is also divisible by 6. Now, there is no easy rule to check the divisibility of 7, so we will skip 7, but we will learn to check the divisibility of 8. So for that, the last three digits should be divisible by 8. For example, 1432, so the last three digits are 432, so 432 is divisible by 8. For this number, 2,465,624, the last two digits, again, these are divisible by 8. So this complete number is also divisible by 8. Now for this complicated number, the last two digits, which is 376, it is also divisible by 8. So this complete number is also divisible by 8. Now let's check the divisibility of 9. So the checking criteria for divisibility of 9 is similar to the checking criteria for divisibility of 3. So all you have to do is to sum all of the digits, and that sum should also be multiple of 9. For example, 18. Now 1 plus 8 is 9. So 9 is itself a multiple of 9. So 18 will also be the multiple of 9. That means we can say that 18 is divisible by 9. Now 2376. So 2 plus 3 plus 7 plus 6, which will make it 18. So 18 is divisible by 9. So 2376 will also be divisible by 9. So now this number 73,957,662. So adding all the digits, we have 45. So since 45 is divisible by 9, therefore this complete number is also divisible by 9. Now for the divisibility of 10, that is an easy one. So the numbers ending with 0 would be divisible by 10. That means 40 ending with 0, this number ending with again 0, and this complicated number ending with 0 will be divisible by 10. Now for the divisibility of 11 is again an interesting one. So to check the divisibility of 11, all you have to do is to keep subtracting the unit digits from the remaining part of the number until you find a multiple of 11. What does it mean? Let's see with some of our examples. So 154, according to our instruction, we have to subtract unit digit from the remaining part of the number. So here the unit digit is 4 and the remaining part would be 15. So 15 minus 4 is 11. As you can see, 11 is a multiple of 11. So 154 would also be the multiple of 11. Let's see another example, 2475. So now we will separate the unit digit, which is 5, and we will have then 247. So 247 minus 5 will be equal to 242. As you can see that 242 is itself a multiple of 11, but if you cannot notice it yet, then you can repeat the steps. So subtracting 2 from the remaining part, that is 24. So 24 minus 2 is 22. Now as you can see that prominently 22 is divisible by 11. So that means 2475 is also divisible by 11. Now let's take a complicated number, 258,071. Let's see if it is divisible by 11 or not. So all we have to do is to keep subtracting 1 until and unless we get a multiple of 11. As you can see that subtracting digits 4 times, we end up at 22. So 22 is divisible by 11. So this complete number is also divisible by 11. So these were the tricks to check the divisibility of some of the numbers. I hope you liked our lecture. If yes, then do like our video, comment and share it as much as possible. And if you like the concept of NoorulRiazi, then do subscribe our channel and follow our Instagram page with the same handle. So see you guys in the next video.